Good day. Sorry I'm a little late. My son walks in at the last minute and says, "Here, try this camera." So he unplugs it and plugs it back in. So I'm not red anymore, but now I got to shave and make myself look all pretty and stuff because it's an HD camera. Last minute stuff. Wonderful, wonderful. Hope everybody's doing okay. Can everybody hear me okay? Okay, good. Yeah, I didn't test the audio on this thing. All right. So let me get back to the right one here. I got too much stuff open as usual. All right, so we were talking about footings the other day, and let me make sure that I'm recording. Yes, I'm recording. We were talking about footings the other day, and we talked about piers, piles, and all of that good stuff. We talked about seismic movement. Did we talk about seismic movement in here? Okay, all right, cool. Mountainous, flats, coastal, soils, yes. Piers, spread footings. Okay, so we got into piers, and let's talk about spread footings. So spread footings is, I kind of hit on this a little bit the other day, but so we have basically our foundation wall coming down, and then we have what we call a spread footing or continuous footing in this case. And what happens is we are taking, whatever the kips that we have here, the downward forces, and we're spreading them out over more area. And we kind of talked about that as far as, putting a pencil in the ground and so forth. But how do we determine this size? So as a rule of thumb, now this is not always the case, but as a rule of thumb, as we're talking about a single or two-story house, and when I say single or two-story house, then hang on just one second. I got one student that can't find the link in your email. Okay, so basically, let's think of it like this. Let's say that this is X. All right, that's the dimension of that foundation wall. And again, this is talking about 1 to 2-story houses. And this also could be plus a basement. So, don't count a basement as a story, even though, really it probably is. But in the code, they separate the basement from the rest of the stories of the house. So we're talking about a 1 to 2-story house, and it could or could not have a basement. So if this is X, then this is going to be X, and this is going to be 2X. All right. So 2 times the width of our foundation wall, and the depth is equal to our foundation wall. All right, so there are some limitations. The code says that we cannot be less than, so we've got to be greater than or equal to 8 inches on this foundation wall here. All right, we cannot be any less than 8 inches. So generally, we're going to use an 8-inch CMU, or we're going to use 8-inch poured wall. And there's a lot of other ifs and sort of kind of maybes that goes along with this. All right, so if we're out here on the ground, and I'm just going to make me a line across here. This is earth. This is the finished grade. All right, now again, I said this is finished grade. This is not the grade in which we get out there and we've put some, we've done our bulldozing, we've pulled this down, we're pouring our footing, and that's not finished grade. All right, finished grade is, they consider finished grade as far as, if you're going to add mulch, if you're going to have grass. So, when we get through grading, and let me just put this other little line down here. When we get through grading, this is what we call mineral soil. All right, so mineral soil is, mineral soil, I probably should try to write a little bit better so you guys can read this. Mineral soil, and forgive me if I'm not spelling it correctly. Dyslexia controls my life, if you haven't figured out already. So this is mineral soil. And so mineral soil is that dirt, hard, clay looking crap that, you get all over your car, you step on it when it's raining and it's stuck on your boots and it's just yuck, mucky stuff. Finished grade is, it has some topsoil on here. And topsoil is what we can grow stuff in. We can't really grow a whole lot in this mineral soil. Mineral soil is just, it's got rocks and clay and all of that good stuff. But topsoil has organic material in it. And we can count this topsoil as far as getting to our finished grade. Now, here's where the code comes into play and is really, really specific. The bottom of this footing must be below the frost line. And we discussed that the other day, with the heaving of the house. So we have to have this setting on non-frozen ground. All right. So in Burke County and most all of North Carolina, it is equal to 12 inches. All right. In the mountain counties, and I think that includes Buncombe, but for sure it's Macon, Watauga, Yancey, all of those, all those mountain counties across the top, it's 18 inches. Okay. So for the majority of North Carolina, this is the big number. All right. But for the mountain counties, they have to go a little bit further. Now let's go up north a little bit. My son lives in upstate New York. Now let me say this. In lower state New York, lower state New York, it's got to be 48 inches. But in upstate New York, where he's living now, it's got to be like 53 inches, I believe it is. And the further you go up north, the deeper and deeper and deeper it gets until you get up to a point well above the Arctic Circle where the ground does not freeze, or where the ground does not thaw, where the ground does not thaw. And then it goes back to zero. You can just put your foundation directly on the frozen ground, permafrost, and it's going to stay for a while until the planet warms up a little bit more and all of that ice starts to melt a little bit more, and that turns into dirt and mud and crap, and the house starts sinking. So for the biggest thing here, we have to be, and this is greater than, and let me just get rid of the equal to, because really if you're just equal to, you're probably going to get turned down. The building inspectors like to see this deeper than 12 inches. They don't want it to be, 12 feet or 12 and an 1/8 inch. They want to see some, they want to see it a little bit deeper than what it is. And that's why I put in greater than 12 inches. And the mountain counties, again, is also greater than 18 inches. So that we're well below the frost line and we're not going to have to worry about any kind of heaving and mess going on. And this, again, is called a spread footing. And you'll see it sometimes called as a continuous footing too. And the reason that it's called a continuous footing, let me come down here and let's see. I don't know if I have anything open right quick. Let me open one right quick that I definitely know has. This is one I completed not too long ago. If it'll come up, there we go. All right, so let's go over to the footing foundation plan, and you see this dotted line. I've highlighted that dotted line. Matter of fact, I'm going to change the color on it so you can kind of see it a little bit better. So the red line right there that you see running around is that continuous footing. So it is continuous all the way around the building. And, you know, even over here, when we're talking about the garage here, it has its own continuous footing. It's nonstop. It's not like the pier footings that we're talking about before, even though these are spread pier footings. Give you an example of that. That's a cross section of it. So the post comes down. In this particular case, we're setting it on a column block, which is basically just a square block that has a hollow center. And then we've got, in this case, 24 by 24 by 12 inch deep concrete footing for this post to set on. Now, each one of these posts is going to have its own independent footing. And even inside where we have posts that are going to come down with inside the house that we have to have girders and stuff on, they're also going to have their own independent footing. And let me come down here to this and kind of show you. It's kind of hard since it's blue. Let me change the colors. Well, actually, let me just do this. Probably be a little bit easier if I just show you in as a printed version. We don't have so many colors and it's not a black background. Of course, it's going to come out with the same daggum colors because I didn't set everything. Here we go. I don't want to save it. Oh, I know what I'm doing. I want to preview. Sorry. There we go. So you can see that gang stud. Oh, come on. You can see that gang stud that, you know, is closed up in that wall beyond sets on this big 36 by 36 by 12 footing that is not part of the slab. The slab goes over top of it, and any weight that pushes this down and has any settling, then this is going to separate itself from the concrete slab, and this is, you know, this can push down and the slab is going to float and stay in place. Notice on this side, the foundation wall is independent of the slab, even though on this side where we have a daylight wall, the slab sets on top of the foundation, but then we have this wall that kind of compresses it down. This cannot float very good. This is going to kind of, you may actually see some cracks in this if this wall settles over the course of its lifespan. And generally, a lot of that settling takes place within the first year, the majority of it. And then depending on the weather, the climate, and any flooding or anything that might take place, then it may or may not settle any further after that. So, but that kind of gives you an idea of that spread footing for a post, or what we call a pier footing. I seen something a minute ago that I needed to fix. Oh, yeah, okay. I remember what it was now. So because this is a minimum, all right, it's got a, you know, a minimum foundation wall of 8 inches, then that also means that this, you know, X here, which is equal to the X up here, this also cannot be less than 8 inches. So it's got to be greater than or equal to 8 inches in thickness. That's the smallest that, you know, that is allowed by code. Width-wise is a whole different story. You'll have to go into the code book and look at that, depending on this, you know, depending on if you're 1-story, 2-story, if you have a basement. There's a whole bunch of things that go on there as far as the minimum is concerned. But now let's think about this. Let's say that we look in the code book and it says that, okay, so we have a 1-story building and it still has a garage, and it says that we can make this footing 1 foot 4 inches wide. All right, so 16 inches wide. So we're going to call the grading company, and they're going to come out and they're going to start grading this off. Now, hold on a moment. What size is his bucket? Does he have a 16-inch bucket? Probably not. Does he have a 20-inch bucket? Probably not. What size bucket is he going to have? He's probably going to have a 24-inch bucket. And that is what is going to determine what size these footings are, because he ain't going to go out and buy no special bucket just because, you know, you can get by with a 1 foot 4 inch. It's going to cost you more in the long run to, you know, have him go out, buy a special bucket, come back and do the digging, and then you use less concrete. So he's going to use whatever bucket he has, as long as it does not, as long as it's not less than. So as long as we're greater than whatever is, you know, is by code, we're okay. Okay, we don't have to get nitpicky on this, because we've got a production that we've got to meet, a deadline that we've got to meet, and, you know, we got to keep moving forward, and we can't get bogged down by, you know, small, subtle things like 14 inch or 16 inches versus 24 inches. So don't let that scare you. So another type of footing, and we talked a little bit about that floating slab. So just to give you, let me kind of back up, and I'm going to talk about this a little bit more here in a little bit. The floating slab. So we had that, you know, continuous footing, and then we had that slab that just went up in here. And according to code again, and you're going to hear me throughout the entire semester talk about code, because code determines what we can't build and so forth like that. This area right here, where these two come together, they cannot bind, they cannot touch. So when we're pouring this concrete, we have to put some sort of something there. And most of the time, whatever the under slab plastic is gets turned up. We pour the concrete, we come back and trim this off, and we're good to go. This is not touching this, and this has the freedom. No, actually, let me say this a different way. This has the freedom to move up and down. Most cases, it's going to go down, I promise you, because this has got a whole bunch of weight on it, where this may have just a little bit of weight on it. So this becomes a floating slab, meaning that it's going to hopefully stay in the same position while this over here fluctuates up and down. Most, like I say, most cases it's going down. So if we were to tie this in, let's say this go a different route here, and we're going to put our we're going to pour our concrete wall right on top, or pour our concrete on there. We're going to put a wall right on top of that. Then this is no longer floating. And if this goes down, because there's a lot of area over here that has some, you know, some anti-forces that's pushing back up from it, this is want to go down. This is going to crack right here. And then this is, you know, you're going to have a mess, terrible mess. So we try not to do this if at all possible, especially for more than one, if we have more than one story. Now, what can we do? If we have a story, or, well, let's just say equal to, or I can't say really less than, but anyway, we're no more, let's just put it this way, no, can you spell no? No more than one story, we can do a slab on grade, and it's called a monolithic slab. So what happens is we're basically pouring our footing and our slab at one time, and that word is monolithic. Look there, I can spell something after all. So we have a monolithic slab that has a whole bunch of reinforcement in it. We're going to talk about the reinforcement today as well. And so we've got a beefed up footing here. How big is this footing? Depends on how big the backhoe is. Probably 24 inches. How thick is this? Generally, it is around 4 inches. Now, 4 inches for a house, 6, 8, 10. How about trying 12 feet deep, 12 feet thick? There is a wind turbine nacelle testing site in I can't think today, Charleston, South Carolina. And this thing is enormous. The nacelles, let me explain to you what a nacelle is. Find a good picture here. There we go. This is a nacelle. All right, so these larger wind turbines here, these nacelles here are large enough for you to get into and walk around. This is probably about the size of a good size job trailer, work trailer. They can be enormous. And, you know, when we're talking about megawatt, and well, I mean, there you go. There's how big that nacelle is compared to a person. You know, we're talking about a megawatt here. Right now, the largest, to my knowledge, wind turbine is a 14 megawatt turbine. Now, how many of these huge 14 megawatt turbines do we have in the United States? Absolutely none. These are mostly overseas, Germany, Norway, and so forth, places like that. But, you know, the only wind turbine nacelle testing site, to my knowledge, is in the United States. I guess probably, there we go, nacelle, spelled just like it sounds. South Carolina. Let's see what we got here. It's Clemson University. So there's that building I was trying to get to. So these nacelles are brought in now. So there's a person next to one of those generator nacelles. They bring these things in by ship, and they put them on this. This is a great big engine here. The nacelle sits on here, and this engine turns on and basically takes this nacelle to its breaking point. It's there to destroy this nacelle. You know, it's testing the transmission, it's testing the generator, it's testing all of these things so that, you know, like I say, beyond breaking point. And so this concrete pad right here, this is just a representation. This concrete pad is 12 feet thick. Matter of fact, there's probably a better representation of that nacelle pad. 12 feet thick. Unbelievable, just solid concrete all the way down. But for a house, 4 inches thick, that's all you need. If we got a fire station that's going to have a lot of heavy trucks on it that are full of water, then we're probably going to go to about 8 inches. If we've got a concrete company where we're going to have heavy concrete trucks running across it, 8 inches. So depending on what's going to be on here, and you and your spouse and your kids, 4 inches is about as bad as it's going to get. You're still going to be required to put rebar in. We're going to talk about that rebar in a minute. And you're going to be required to put in metal reinforcement through there. But now, again, we're not putting a 2-story house with a basement and all of this on it. So we've got just minimal weight forces that's going to be coming down on this thing. And hopefully, if we've built this with the right amount of reinforcement and everything, this is not, you know, the whole thing's going to settle at one time. Go away. Okay, so all of this hopefully is going to have the same amount of settling and anti-forces on it throughout its entire life. Non-traditional footings. So let me just back out of here for a second. Believe it or not, yes, you can build a wood foundation all day long, providing that you use the right, uh, tools and so forth that are listed in the building code. I'm not so sure that I would want one in Western North Carolina. I dang sure don't want one in Eastern North Carolina where their termites are about the size of a large rat. But, wood foundations can be used, but you're going to end up spending a whole lot of money trying to get these things waterproofed, that maybe not they will work properly. What about precast foundations? Precast foundations, and the biggest, probably the most popular is the Superior wall. You've probably seen Superior walls, on a truck somewhere. These are Superior walls, and they are made in a factory uh, in pristine conditions. And we're going to talk about pristine concrete and how to get pristine concrete. So these can be used. This foundation, believe it or not, can be erected in less than a day. If they get started about 8 o'clock, they're probably walking away maybe a little after lunch, maybe 1, 2 o'clock with a done deal. So this is the new way of going. Now, look at the footing that it's sitting on. These are designed because they have this rebar in it. And again, they're made in pristine conditions with rebar all through them. Then they don't need a concrete footing. You actually can put down a gravel base footing and set these directly onto it. And then when you pour your concrete up to it, again, you've got to allow for this to float, or this to move up and down, and this to stay stationary and float around. So Superior walls are becoming a more sought after. It's a little bit more expensive, but you don't have to, you don't have to pour concrete footings. It can be put in a day, and the next day you can start framing. There's a lot of pluses to this. The only negative thing, to my knowledge, in the Superior walls is that it is a little bit more expensive. But then, you got to also think, well, if we build a concrete block wall through here, then we're going to have masons out here. We've got to have, they're going to have equipment. We got to have the block. We got to have the mortar, and then we're going to put in some other reinforcements that's going to go in there. So this is a very good alternative to the average, traditional footings and foundations that we have been using in the past. And I've had a lot of students who have used this not only in their own house, but they have actually become contractors, and they use this a lot in the houses that they build. So this is something that can be looked at as well. Steel foundations. Let's take a ride. So it's only going to take me an hour to get there, but it's going to take you guys like 2 hours to get there. So we'll just go virtually. So leaving from my house here, we're going to fly up to Blowing Rock here. And let's start about right here. This is the road going up to Blowing Rock. I got to move this stupid thing again so I can get to my little person. And you may see some of these houses. Let's go up the hill. You may see some of these houses around Asheville. I don't know where they are, but I can definitely show you where they are around here. Nope, not there. Is it there? No, I ain't got there yet. I don't think. Maybe. Did I miss it right here? No, it's not there. You know, it may be a little bit easier doing it this way. Maybe I went too far down. Yeah, I did go too far down. See that house right there? That's the house that we're gonna look at. We're gonna look right up under its skirt there if we can. Well, maybe I was in the right place. You just can't see it anymore. Huh. It's all grown up. There it is. There's the house, but you can't see it anymore. Doggone it. Last year's Google picture, it was done in the wintertime, and you could see all of the bracing and the skeleton stuff up here. So maybe that wasn't such a good one. But if you go driving up there right now, I promise you'll be able to look at everything. House on side of mountain. See what we got here. See if we got any good images with some crazy metal. There we go. So here is what we call metal foundations. These foundations are embedded into the rock, and it's one thing to say, you can't hide money, but when you go and stick it on the side of the mountain like that, you definitely can't hide money, because it takes so much more engineering and so much more work, so much more effort to get these big pieces of steel put into place and set exactly the way they need to be on the side of the mountain, so that we can put our pretty little house here and have our $1 million view. That's exactly why they do that. No more, no less. They want to look out and they want to have a view that will, that would kill their great grandmother. So it's, what kind of view are we talking about there? And of course, I'm not going to be able to get to it. That's the kind of view that they're looking for right there. All right. That's the $1 million view. So you can build literally, you could probably build a $25,000 house on a ridge that has a view. And believe it or not, you can sell that for $1 million just because of the view in it. And it's really sad, but especially folks that come from the bigger cities, the state of Florida, where they're not used and accustomed to a mountains, man, when they can get up and see something, it's kind of like King of the Mountain. Why we play King of the Mountain? Who's going to be on top? So if you're up on top and you can see the rest of the world, then you are King of the Mountain. Oops, wrong one. Okay, so there's lots of stuff, like I say, there's lots of videos in here. Let's talk about the wrong way to build while I'm at it right quick. This is a house that is not very, well, should I say was not very far from me. As a matter of fact, let me just take you there. We'll go back to my house for a second. I love showing this particular house. So here's my house. So I'm sitting right over here in this corner here, and let's go right here. All right, so here's this is the road that I live on, and then the extension goes, and I mean, this is almost dang near straight up the freaking mountain. And then look what's left. All right, now let's take a look at what happened here. Let me go down here to the beginning first before I show you all of those other pictures. We'll start right there. All right, who builds a house and then decides afterwards you're going to put in some plumbing, a bathroom upstairs, and you're going to have to raise the floor up to do so? Hopefully this is already in the planning. You've made your floors thick enough to where you don't have to do stuff like this. All right, so we've got a door to nowhere. This is the second floor door. You can't do this, with code. You can't put a door that is accessible to the outside, and it is more than 4 feet, I think it is. But, well, we can put a lock on this, but let me tell you something. Unless it uses a key on this side, it's illegal. All right, a small child open that door, fall out, it's going to be gone. Beautiful, just absolutely beautiful setting. But then we get into some problems. So what had happened, so let me back up a little bit. What had happened was this house was built, and it was put on the market, And these are actually pictures that were put up on the market. I don't know about y'all. I mean, that's the overlook. All right. So there's that $1 million view. There's the house that came off of the real estate ad. This came off the real estate ad. I would at least cleaned up a little bit if I was going to put something on a real estate ad, fix the tile in the kitchen. You know, these were pictures that came from the real estate ad. So it was sold to a family, and the family wanted to get off of temporary power. When they got here, they found out right down here, it's kind of hard to see, right down here was a power pole, and there was a temporary line that ran up to the house and into the side of the house somewhere here. I don't remember exactly where, but so, you know, they went to the power company and said, hey, we're on a temporary pole. We need to get off this temporary pole. So, you know, they said, well, let's look into it. So the electrical company called the building inspections office to get a permit to do so. In other words, what happens today is we want to get a home that to have power, and in order to do so, there are a few houses like this on Windswept Drive near downtown. That's from Josh. So okay, so there are some houses that's up off of the ground there and in the middle of nowhere. So we have a house that we want to get power to. And so in order for the power company to come up and put a transformer up there and roll it down here, there's a big old roadblock in here called the building permit. All right, this is the only way that you can get electricity from the grid to your house. You have to have a building permit. It has to be passed, and you know, it has to be passed. You have to have the electrical inspection mainly. All right, so you can build a house and you can get a temporary, or let me say this, you can get a temporary. All right, so here we're going to go out here, we're going to put a pole in the ground, we're going to put a temporary on here, and then we're going to have power put to this temporary. And then now here's the where it really gets kind of dirty. By law, you can't run a cord from here to your house. Okay, you can have an extension cord, but you can't run it. What am I trying to say? It can't be hardwired. That's what I'm trying to say. It can't be hardwired. You can run an extension cord, and that's about it, because it's very illegal. So to get the power run directly to your house, you got to have that building permit. So they called the building permit office, and lo and behold, they can't find a permit that was ever issued for this house. All right, so this house was built and no permit was ever issued. How do you do that? How do you get a house built this far? Well, because it's setting up here in the middle of God's country. That's why. That building inspector, he don't give a flip if he sees it going up through there. You can go out here and build a house right now if you want to all day long. You don't have to have a building permit, but don't expect electricity from the grid to be put to your house, because it ain't gonna happen. So that's what they done. There you can see that this is a temporary line that the owner had put in from the line. Now let's go back and let's kind of look at this a little bit more. So anyway, the building inspector, he got to looking at this, you know, where they had sold this. So the homeowner, the current homeowner, had showed them where they had bought it. So they got on here and started looking. And the building inspector's looking at this saying, wait a minute, this is a beam. This beam holds up this portion of the house and this portion of the house, and this is a fireplace. You can't do that. So wait a minute, is this the first floor? This is the first floor, okay. So we're standing on the first floor, meaning that underneath it is a beam that's going into the fireplace. And son of a gun, if we don't have another beam going into the fireplace. Again, So they just had a time with this, and county made them tear it down. So let's look at what was going on. What was so wrong about this house? Let me just back up here and start back over here. Here's that one picture where the beam went into the fireplace. Big no-no. All right, can't do that. So this beam here is not pressure treated, meaning that it can't set on concrete. So the homeowner, he erected a pole beside of the foundation that had a piece of pressure treated wood on it to lift the beam up off of the concrete. That, is it code? I mean, that's kind of like picking your nose with a razor knife. I mean, you just don't do stuff like that. Another header, non-pressure treated, setting directly on concrete foundation. There's that beam going into the fireplace again. There's that beam from above. And so to give you a little sense of what is so illegal about this is there must be 2 inches of space between any masonry that contains a flame from any structural member. 2 inches, clear span. And you can't bear on anything that holds a flame, period, nothing. Notice over here, they put another stand up here to pull this up off of the block. Non-pressure treated homemade girder there. Very illegal. There's another view of it. Now, the code also says that we must allow for a 1-inch airspace all the way around any place where, this is called a beam pocket, by the way, or a girder pocket. This is a girder or a beam. But so you have to have a 1-inch airspace here to keep moisture at bay. Now, in this picture here, I want you to take another gander at something. A beam or a girder takes weight from a point here to a point here, and it wants to support it through the clear span. Look where that joint is. Look where that joint is. You don't do stuff like, you can't put joints in the middle of a free span. Here's the really pretty picture. Let me go back here just for a minute and show you. This is where this house was setting. All right. We are looking due west. All right. Due west. There's nothing between God and this house. There's the house. Notice that there's not a whole lot of forestry on that west side of the house. And we have the wooden portion of the house and the masonry portion of the house. What's missing in this picture? Can anybody tell me? Anybody with some construction experience can tell me, and you can just chime in and tell me what's missing here.
Silt fence?
Say it again.
Silt fence? Oh,
silt fence? No.
What?
Eric, it seems like there's a whole lot of things missing in this picture.
What's the main thing missing?
I'm guessing that you're looking for something that may have been there before, but then got removed. But
Nope, it was never there to begin with.
Yeah, I'm not seeing any sort of, right now I'm looking at a picture where I'm going, well, there's nothing, there's no capillary break. There's no sill seal there. They've capped on top of the block.
Okay.
Sure.
What about, what about that? What are those?
Yeah, so there's no J-bolts to fix the framing to the top of the foundation.
The house literally is setting on top of the foundation, meaning here's the foundation and the house is setting on top of this, and it's not connected. It's not tied to the foundation at all. So if this hurricane that we had this past fall had come through here, whew, this house would have been gone probably.
Well,
Okay.
they probably just shot it with a bunch of redheads. It'd be fine.
No, there was no marks on this wall anywhere to indicate there was anything, not even strapping on the sides.
That was their earthquake proofing so that the house could just move in the earthquake.
Oh yeah, right, so it moves. Yeah, exactly. Yeah, absolutely. Unbelievable. So, by the time that the building inspectors got to this, they didn't even want to see how much foundation footing, how thick the footing was, if it was under. They called it, and a lawsuit took place. I think
this house be sold without an inspection. It had to have had an inspection, right?
no, you can sell a house without without any kind of inspection. Basically, I can sell my house today to you, providing that you don't have to take out a loan. If you can pay me cash,
right,
then you and I can go to the courthouse, sign papers, and it becomes yours.
Yeah, I've experienced that before. I just, if the buyer's not taking their due diligence period, I just don't know how the house could be sold without even a certificate of occupancy, and somebody actually go pay cash for that.
Yeah, exactly. So who was the bigger dummy, the people building it or the people that bought it? I don't know.
Yes.
So yeah, like you say, there is so much wrong with this picture. That's crazy. So just for fun, see this here? This was the front porch. Notice that it has shingles on it. Well, the well, see that pipe there? The well is in there. You can't cover a well with a house, not without having some sort of contingency to where you can get the well pump out. I actually had that happen. It can be done. And so basically what had happened, the only place to put the well was just so happened to be the only place where you could put the house. So we built the house, we put the well in, and then we built the house over top of it. But the only way that we could do that is we had to make sure that there was a chase all the way, through it had a basement, had a first floor. It was actually a split level house, but so we had to make a chase all the way up through into the roof. And then we ended up putting, basically what happened was we put a 4-inch diameter pipe, and we put a cap on it so that whenever the well pump had to be pulled out, it could be pulled out through the roof. So, crazy stuff does happen. You just gotta plan for it ahead of time. Nothing was planned ahead of time. To this day, we still can't figure out what these 2 holes here are for. I've been over this house with a fine-tooth comb several times, and I don't know, can't figure it out. So anyway, if anybody is looking for a nice home place with a foundation that you're going to have to tear down before you get started, and it even comes with this outbuilding here, 6 acres of land. There it is. I know where it is. You'll live very close to me. And you can, like I say, this is fairly new, probably this year, and there it is. The road going to it, the road from here to there is paved. The road from here to there, you better have a bulldozer. For me to actually ride my motorcycle up through here, there's holes right in here that would probably engulf my entire motorcycle. So not cool. Okay, so let's talk about drainage as far as our footings. So in our site work, we've got to take in, you know what, I tell you what, let's take us a break before we get into this. So take us about a 10-minute break, and we'll come back at 1:33. Okay, so let me see who all's on here today. Somebody had sent me a text message asking how to get the email. So Josh, where did you finally find the link to today's Zoom? Is Josh here? Yeah, Josh is here.
Hi, I'm here. I found it in my email eventually. It was just under my, what is it here? Where did I find that?
We had another student that couldn't find it, and I just want to make sure that they can find it in the future.
Under the calendar, under your Outlook email.
Okay. Okay, yeah. So if you look under your calendar, so if yours is like mine, then you just hit calendar and then you can go to that. Okay, good to know. Thank you, sir.
And the link that you sent originally in the first email still works for this also.
Okay, good. Okay. Okay, so let's talk about drainage. So I'm just pulling up the PDF from the Journal of Light Construction on foundation drains and the such. And let's talk about that for just a little bit. And while we're on the notion of drainage, I also, if I go on to something else, remind me to come back and talk about septic systems as well. So according to code, we have to provide a drainage all the way around the foundation to rid ourselves of any water that just so happens to get, down deep into this. And sometimes you might be above the ground and you're going to have to use sump pumps in this as well. But before I get too far on the sump pumps, let me just see, might end up just drawing something. Yeah, let's just do that. Okay, so we have our footing. We've talked about the footing there. We've got our foundation walls. And so what we've done is we've come in here to our natural grade and we have cut this down to generally about this point here. Okay, so now we've got some other, and you should, excuse me just for a minute. We've got a student that had the disk got disconnected. All right, so, we've, this originally, our ground probably went down through here like this, and obviously we can't build a house, looking like that. Oh, while I'm at it, let me just, remember in kindergarten when you had that one person that always drew the house and the chimney was stuck on there like that? I always loved that. I always just think that's kind of cute. So what we've done is we've come in here and we've taken our natural grade and we have flattened it out to where we can, we can put our house in here. So we dig our trenches for our footings, and we start backfilling. So we're gonna, let me change colors on that. We're gonna backfill this here. All right, well, so we had to have some space in here so we could have a person come in here and build these walls up without the fear of, this falling over on the person. So we end up backfilling this. So over here, this is undisturbed soil. So we're going to call this a 100% compaction. And over here, this is not going to be 100% compaction, meaning that when we get any type of water in here at all, rain, snow, whatever might be happening, that water is going to go here first. All right, because this is less dense. It's not as compacted as the earth that is over here that we didn't touch. So this is where the water is going to go. And, water seeks the least resistance, in other words, to go to different places. So let me finish this out here. We've got our pad here. We're going to have some gravel that's going to go underneath here that we'll talk about as well. And so remember that this is not attached to the wall. And really, the only thing that's going to hold this together here is some rebar. Okay, we put some rebar in here. There's not really a seal per se that is put in here. Should be, but there's not, unfortunately. So what we have to do is we have to go in here and we're going to put a pipe. Now, again, this pipe, depending on where you are, remember that, we have soil that we can dig into, and, we can pour our footings in here. That it's going to be coherent enough to where it'll stay in place, or cohesive enough that it's going to stay in place, and we don't have to put any form boards. But now when we get out west, or not out east where the sandy stuff is, we're going to end up building a form. We're going to pour concrete, and we are going to end up placing that drain at this point here. So depending on who you talk to, where's the right place to go, here or here? Who knows? As as a thermodynamics person myself, I picked this place because the weak point just so happens to be right here in most cases, in those two places. So we also have to, we're required to put, this is a 4-inch drain. And then we have to have some gravel, 12-inch minimum gravel. And this is washed gravel, by the way, and I'll explain that a little bit later. Washed gravel, washed stone. And then we also have to put a silt screen across this thing. And this keeps all of our fines from getting into this. All right, remember that the dirt that we have here in Western North Carolina is full of clay and all sorts of fines. So when we backfill all of this dirt in here, then there's going to be some small particles that we have to worry about getting into this and clogging up the gravel, clogging up the drain. So we've got to put this silt screen across through here. Believe it or not, the code says that you can put builder's felt or tar paper over this thing, but I would suggest you don't. I would suggest you actually use a silt screen. Now you can purchase drain pipe that is already covered with the silt screen, and it has peanuts in it that there we go. You can buy this that has the peanuts, the foam peanuts in it, and the silt screen over top of it. All you can buy. It's sold as a French drain, and you can put that down. It's very legal. It's fine. These peanuts take place of that washed gravel that I was talking about. So this is doable. You can do this. I've seen this all the time, and you know, this might be the preferred method by a lot of the contractors. I don't know. You can also buy the pipe with only the silt screen on it, and then you can put gravel over top of it. Unfortunately, the code says that you have to go back over top of this with gravel and then a silt screen over top of that. The silt screen has to cover the gravel and the pipe, not just the pipe. So I'm not seeing any pictures of those anyway. So, you know, we've got to have that silt screen, that it has to be on top of the gravel or the peanuts, the foam peanuts, not just over the drain pipe. So water is going to get down through here. Now, this is the only thing that is required by code as far as a drain is concerned. It says that we have to go across the foundation wall with a couple of things: 3/8 parging, and then foundation coating. And this foundation coating is nothing more than tar in most cases. All right, so we have to have at least these two. All right, now what is parging? You're going to hear it called all sorts of things: stucco, mortar, any number of things. Basically, all it is just, it's just a mortar concrete mix that's put on the wall, the foundation wall, and helps seal up the foundation. So, you know, it's just concrete. That's all it is. It's just a concrete mixture or a masonry mixture that goes on here just to seal these blocks. That's all there is. Or concrete. In other words, this case, this particular thing is going to be concrete, and it's just covered. And then we can put the foundation coating over top of it. And this is in a bituminous material. So that's basically what it is. It's a bituminous. It can be sprayed on, it can be painted on, it can be rolled on, and it's just a bituminous or tar coating that goes on top of that. Now that's the end of what the code requires. So we could take it much further on this as far as code is concerned. Let me go back and let me back up here and get rid of some of this mess here where I can make a prettier picture.
Eric, I'm following along here with the Journal of Light Construction PDF. You know, your figure C on placing your footing drains there. You know, it's got those two on the left as best practice, and only one of those three has the footer drain on top of the footer. And
Yeah.
my understanding is the reason for that is that footer drain is going to be dealing with a lot more groundwater than surface water, and you should be addressing your surface water in other ways first. Yes, the footer drain is going to deal with some surface water that gets down there, but One of the reasons they're recommending having your footer drain alongside your footer is so that the groundwater gets dealt with and your footers don't sit in water.
Right. I understand. Okay, I agree with you that a lot of the houses, okay, for one, technically you're not supposed to build a house in a flood zone. All right. So where is the flood zones? You can actually pull up maps. Let me go to the Burke County GIS. If you've never been on the Burke County or never been on a GIS map, go to I'm just going to Burke County because this is the one that I use most of the time. You can go into these and you see all these blue markings. Those are creeks and so forth and through here. And let me see where the layers are. Flood zones. All right, so it will pull up your flood zones. So let me take you over here. So you see that's called Hurley Place right there. Let me just turn on the picture right quick. This is my dad's home place, and the whole old house that my father was born in was right here. Now I'm going to turn off the floodplain. Here's the Henry River going out through there. All right, and again, we're talking about, when I address most of this, I'm addressing what we're going to see most of the time in a mountainous region, such as Western North Carolina. Now I'm going to turn on the flood drain. All right. So technically, we cannot build a house anywhere in this blue area here, meaning that there is going to be water that is going to be settling here. Now, if I could go down east, these get larger. But let's take a look at my cousin's house here. So this is a house that I built back in '95, and it's a hilly, it's very hilly. As a matter of fact, let me turn on the contour lines. You can see here that, you know, the creek is over here. We've got a field here, and then all of a sudden, wham, it goes straight up the freaking mountain here. So what kind of groundwater are we going to have to deal with? Not so much here, because it's going to run down. We're going to have runoff that's going to run down. And the groundwater that we have in these regions here are going to be pretty deep. So when I'm looking at something like this, and again, it's got to, you have to look at, when you're building your house, per region. It kind of goes back to climate and where the thing is going to be built. And you're going to be you're going to be required to test types of groundwater. Now, in most of the Western North Carolina regions where houses are going to be built, they're on a slope to where surface water, let me see if I can get to where I can move this around, where surface water is going to go around, but groundwater is either going to be very deep and not so much come to the surface. Now, when you think of groundwater coming up to the surface, let's say you go outside after a rain, where does the water puddle up? Where is it dry? At my house, it's completely dry. I live on a slope, and there's just really, and you know, so groundwater, when you think of groundwater is water that is underground, okay, that comes to the surface. And in some cases, it can be very close. Let me go back over here and talk about this again. The well house is right there. We drilled that well, and we hit water at 10 feet. So really, through here, there is a natural spring. This is not within this flood zone here, but like I say, there's a natural spring. So when it rains, after it rains, there is constantly a flow of water coming from the ground right here. And that was one of the reasons that we didn't build it. Let me see if I can show you one other place right quick that's actually pretty cool. Just got to find my bearings here. It's not, yes, maybe it is. All right, it's kind of hard to see on this picture here. One, because they've done a lot of grading through here, But right here, there's a creek that runs right here. And right here, there's no trees. It's not been forested any. There's just no trees whatsoever. And the reason for that is the same reason that we have this natural spring over here in this area, because there's so much surface water all the time. So if you know that you're going to have surface water and you've tested, then absolutely you're going to have to address the surface water by putting these below or equal to the footings. This one, I don't even know if I'd do this one at all, but do these have, so pipe below the footing, pipe at the bottom of the footing, pipe resting on the footing. These are the three that are probably the most practiced. All right. In this case, being the weak point here, then this would be on a slope where we don't have groundwater. We don't have to deal with groundwater. And then these are where we have to deal with groundwater. But now let's go back to this slope again. In this particular house, we did the, let me just pull this up. We did put a drain all the way around the house. And this is the original house. This has been added on. This is on stilts. So we didn't have to put the drains over here. And so this drains out across this driveway and into this field over here. But because this is so steep here, we ended up going right up here, and there is a French drain that grabs as much of the groundwater that we possibly could catch, and then we actually dump that in both directions off of both sides of that house. So if we were building a house down here in this area, we would definitely want to address that groundwater and get the pipe down as low as we possibly can, because we're going to be dealing with more groundwater. We'll probably be dealing, down here with groundwater. Whoop, didn't want to do that. But then where we have slope and no presence of groundwater, then this would probably be the better way to do it. So it really is going to go from region to region, from site to site, and from placement of site to placement of site. I mean, we're talking a distance of maybe 50 to 80 feet from here to there. This was saturated all the time. I could probably go out there right now, and if I had a pair of loafers on, my feet are going to get wet today, right now. And over here, all the way through here, I'm going to be pretty much dry and don't have to worry about it. So it's like, again, it takes, we're going to have to look at each region of each little site differently. But thank you for bringing that up. That's a very good point. Okay, so we talked about code, and so this is code. This is code. This is code. The parging is code. The bituminous material is code. But let's go above and beyond code. So when I was in business, I had, I made the full mistake, and I just put the bare minimum on there, and I was called back to a couple of jobs because I had some leaky basements. Did just exactly what I was supposed to do. Oh, by the way, let me explain that one other thing too. When you put that parging on here, which is that first coat of mortar, we have to have a cant strip on there. So here's the footing, here's the foundation. We've got to cant this, just what's going to happen is as we're putting the mortar on here, mortar's going to fall to the ground, and we just put it into a slope, pretty much a 45-degree angle, and it's called a cant. And I've seen this, spelt both ways. I don't know what the proper way is. It just depends on what part of the United States or the world that you're from. This is called a cant strip on here. All it does is it's trying to deflect water away from this weak point here, is all it's trying to do. All right, so after that, we put on our foundation coating, which is on the outside of it, and that's code. That's the end of the deal. Boom, done. Always make sure that you put a nice thick coating on that cant strip too. 2 or 3 coats wouldn't hurt you at all. Actually, at one time, the code said that you had to have 2 coats, but I don't know if that's, I don't know if that's still, but you need, more than 1 coat for sure. So the next thing that we would put on PVB. Anybody have any idea what PVB is?
Polyvinyl backing.
Okay, close. It is a polyethylene sheet or plastic. Okay, so 6 mil minimum, 6 mil plastic roll. And if you put that bituminous coating on it, and if you go and put this plastic right on afterwards, it will adhere temporarily to it. You can't put this on and expect it to stay on there for a couple of days before you get backfill done. Okay, it just ain't gonna happen. So you're gonna have to put some mechanical fasteners on this to help hold it in place until you get it backfilled. But this is one of the things that we practiced by putting these putting this plastic on right over top of the bituminous material and taking it all the way down. Now, this is above and beyond code thing. All right, here's where the code ends right there. Bam. You got to do all this other, but we went ahead and we put at the time we put 6 mil poly vapor barrier on there. Sorry, that's what PV stands for. PVB stands for polyethylene vapor barrier. And on top of that, even, I don't need a galaxy pen. Let's go with purple. On top of that, we would put drain mat, rain screen. There's again, there's tons of different names for it depending on where you're from. So this is a drain mat, and this is, you could use that, but not really. There we go. This is the preferred one. This is the type of drain mat that I prefer because it has a silk screen on it. Basically, this is just little plastic bumps here that allow for water to run through this. All right, now, why would we do such a thing? Well, basically, why do we put this here? We put this drain here to make a less dense place for water to gather, okay? So this is compact. This is 100%. We'll say that this is, say, 50%. We'll say that this stone down here is 25%. And we're going to say that that is 0%. So that's where the water's going to go. It's going to go into this place. It's going to go into this gravel, and it's going to go into this pipe. Why not put a long pipe along the edge of this wall here to allow water to get into this and to get into this pipe and get it out of the way? That way we don't have, why do we have leaks here? So in other words, for water to come above this right here, it has to be above that point over here. Water equalizes. So the more water we have here, then, we can actually have it squirting out of here. I've seen it. I promise you. You've heard of the little Dutch boy who went and stuck his finger in the dam wall to keep the water from flooding. Well, I was called to a house one night, and I am kidding you not, this water was squirting probably 10 feet into the middle of the basement floor because there was so much water that was settling out here. Remember, I told you I've made a few mistakes in my life. This was one of them. We did 2 coats of the bituminous material. We put on the parging, and that was it. We walked away. And I learned my lesson on that, because I ended up, because it was still within 1 year after I built the house, it was my responsibility. I had to go back and dig this out and fix it. Okay. So when we went back, I was young in the business. Matter of fact, it was probably my second house that I'd ever done. And so it was a live and learn situation. So this is definitely above and beyond code, and this is above and beyond code. What else could we do? Well, one of the things that also is being done today is we're adding insulation to the outsides of our houses. One of the reasons being because housing is costing more and more and more and more and more so much all the time, then we're utilizing basement spaces as finished spaces. Matter of fact, my basement, when I did my renovation, all of the basement except for one small room is completely and totally heated. So, adding insulation, 2 inches of insulation to this can absolutely help in here, because filling this concrete wall through here, this concrete block wall through here, is useless with insulation. You need to put some sort of skin, thermal skin, on the inside or the outside, or both if you can afford it. It gets a little bit more expensive that way, but if you're trying to get this space down here into a heated space, then you're going to have to add insulation. You're going to have to take super measures into getting this water in and out. You can't stop it. It just ain't going to happen. The water's going to be there as long as it rains. We're going to have this problem. The only other thing that you could possibly do is, like I said in that other house, add yourself a French drain to get rid of some of this rainwater up here so that it does not become down here. Any questions on any of that? Good. All right, so while we're talking about drainage and so forth, let's talk about septic as well. So a septic system, not everybody has the luxury of living near a city, and we have to get rid of our black water and our gray water in one particular place. So years ago, black water has always been addressed. So let's think about what is what. Let's say potable water. Potable water is fairly clean. Potable water is, it can be drunk, but hopefully you clean it first. It's not distilled. It's not purified. It's just potable water. Potable water is basically what comes out of a well, what runs through a stream. It is, we'll call it good. It's good water. Of course, if we go above that, we have distilled water and purified water and boiled water. And all of this, this is what we call drinkable. Is potable water drinkable? Well, you could. I don't know, 1,000 times I've stuck my head down in a creek and drank water out of it. That might be the reason I've lost my hair, but I've done it. I could do it. Things are much different today than they were years ago. When I was growing up at my dad's home place that I just showed you, yeah, I would have stuck my head down into the creek at any time and drunk water out of it. there's different things going on. We've got to worry about herbicides, pesticides, runoff chemicals from other places, acid rain, and even just dead animals. You know, dead animals, they fall into the creek and their body decays, and you can end up with all sorts of real funky intesticle little critters that's running around, and it's not cool. So potable water is good. It's not great, but it's good. We'll say that this is great water up here. Just so you know, we have some of the best water in the world. We also have some of the worst water in the world, but we have some of the best water in the world. Speaking of which, give you an example of that. Again, I'm bragging on Burke County a little bit. And then I'm not happy with Burke County a little bit. So the other day, I think we mentioned the Limbo Gorge. And the Limbo Gorge is here. So Linville Falls this is Linville Falls, the city. This is Linville Falls, the Linville Falls. This is the falls, Linville Falls. And this is the beginning of the Limbo Gorge. Notice how this river winds down through this gorge, okay? Many of people get lost in this gorge all the time. There's road here, there's road here, and there's civilization to the north and the south, and then there's just nothingness out through here, lots and lots of nothingness. So the Linville River dumps into Lake James, and this water, as it steps through, and this is not Linville, I don't know why that's there. The Linville River, as it dumps water into the Lake James here, it is ranked very high as some of the best water in the world. In other words, I wouldn't think twice about coming right here and sticking my head down in there and getting me a big old gulp of water right there. Done it a million times. All right, so the water goes through here into the lake, out through the dams, back into, where have I lost the river all of a sudden, to the Catawba River. Where the hell did the Catawba River go? There. So the Catawba River, okay, it dumps right back into the Catawba River. And look here, it goes right through Morganton, or right around Morganton, right around Drexel, right around Valdez, right around Hickory, and it becomes, well, like here, let's back up. Here's Lake Roadhiss. It becomes Lake Roadhiss. All right, it becomes Lake Hickory. Look at the color of this water all of a sudden. It goes back into the river and becomes Lake Norman. And then Lake Norman goes by Charlotte. And then just south of Charlotte, the Catawba River becomes, where'd it go? Back up a little bit, maybe I can find it. Lake Wylie. Now, look at the population through here. By the time this very same water reaches this point right here, it ranks very high as being the dirtiest water in the world. Okay, so this little body of water from I can't find, I guess because I'm not far enough up. So Lake Wylie is here, Lake James is here. So from the cleanest water in the world to the dirtiest water in the world. But we're going through all of these cities. And each time the water passes through this city, we come in here and we take some of this water out. We come in here and we take some of this water out. We filter it. We send it to, the city. This is Morganton here. And then all of these people poop and it goes right back in that river again. So then somebody down the creek here, they take out the water, clean it, use it, poop it back into the river, and again and again and again and again and again. We have the same amount of water right now in the world as we did during the time of the dinosaurs. All the water that we drink right now has been through some gut of some Tyrannosaurus Rex or something at some point. Okay, so we got to take care of our water. Okay, so that's the end of my hippie speech today. Let's go into the septic tank. So we use this water and we poop it out. Okay, so we've got the black water, we've got the gray water. Now I remember what I was talking about. We got over here to portable water and it was good. So we brush our teeth, we take a shower. So sinks, showers, and I'm going to say washing machines are all gray water. All right. We've got some soaps in here. We've got some dead skins on here. We've got spit in here from when we brushed our teeth, all sorts of things. We've washed dishes. We've got gray water. Now we're going to take a great big and ain't no use. And you know, we take a shit and there we go. We got black water. Okay. There's just no way to get around it. That's what we're going to have, black water. We pee in it, we poop in it, it's black water. We are not going to want to do anything with it, even though if you guys get city water, if you get municipal water, it probably, you're getting all of this water right here, and they have run it through filters and filters and filters and filters, and then it goes back to potable water, or good water. Okay, enough said about that. So let's talk about what happens in our septic systems. Okay, so this is a very good example of what's going on in our house. I'm going to make this a little bigger. Okay, in our house, you'll notice that we have these little P's in here. And this sink up here has a P in it. This toilet has a P in the middle of it. This is not down here. It's in the middle of this toilet here. But anyway, these P's are very important. And what that does is that keeps all the odor and all vermin that might be down here in the septic tank from entering our house. Okay. So how did the vermin get in there to begin with? Well, if we have a septic tank that works correctly, then we have living organisms in here. All right. These living organisms are very important to make this work. Now, we go out through here. Hopefully, the only thing that we have at this point, change colors here. You guys see that big thing right there that says your, screen and everything? That's what I just pulled down. I know you guys can't see that. So hopefully all we have here is, let me just put it a different way, H2O. The only thing we have at this point is H2O. That's all we hope, okay? So it goes out through here and is dispersed into our leach field or drain field. Well, we have critters. We have ants, and we have grasshoppers, and we have little worms, and we have bugs, and we have all of this stuff, and they're okay with water, and they will swim right back up through here, and they'll get in here, and because it's a living thing, and we have a vent up here, and I'm going to call it a faucet down here, then they can come up through here and they can, travel across the top of this water. They can top into this vent. They can travel across through here and they can go back up into the house. Well, when they get to this point, they may or may not like that. Okay. Over here, they can get above the water. There is airspace above this. This water does not go all the way to the top of the tank, and there are airspace up here. Over here, there's no airspace. So these bugs probably get to this point, and that's the end of their little travels here. Let's hope so anyway, especially if it's got water in it. And in order to keep this full of water, when we flush this, we need to have air that can flow up and down through this plumbing vent. As water gets put in here, then this may rise a little bit. The water level may rise, and we're going to expel air out through the vent. We definitely don't want to expel air through here. I mean, you know what it smells like when Uncle Henry comes out through there and uses your bathroom. You don't want to have Uncle Henry's, 30-day-old crap out here stinking up the house. So, we've got to allow for this to take place and stop that at that plumber's P so that we have the vents here. But then we don't want to suck these dry. So when this is flush and water's flowing through here, we want to be able to have air going the opposite way back into the vent so that we end up not sucking these things dry in there. So that is, in a nutshell, what this looks like. So let's go a little bit further. And let's look at the septic tank itself. So the septic tank has two compartments. It has an inlet where it comes from the house, and it has an outlet where it goes to the drain field. Oh, God. All right, so as it comes in here, we have this T here. This is going to be deep enough so that water is covering this. But then we have allowment of space. There has actually got to be some air coming in here. And that might be where this riser is to take in air. Generally, we don't have these, okay, in a regular house. So how this one is here, that's the way it is here. It just comes up, but does not go to the top there so that air can flow back up through here if it needs to be. So in this first compartment here, we end up with our waste, we end up with paper, and whatever else is put in the toilet. Now, here's the thing. How many of you are smokers and maybe throw that cigarette butt in here? Guess what? That cigarette butt filter is made out of plastics that does not disintegrate. Remember what I said? We have living things in here? We do. We have bacteria, hopefully, in here. We have living organisms in here. And what they do, you can think of it as Pac-Man. Pac-Man eats the little dots, and he eats all the little ghosts and stuff. So we have all these little Pac-Men in here, and they're eating all this stuff. And they poop too, but their poop is very small. It's microorganism looking stuff. And so that, and only that, can go over and through this to the other side. So hopefully we keep all of our solid stuff on this side. Whoops. This side. Okay. This is all our solid stuff. Over here, we have our micro stuff and water. That's all we want at this point. Now, what goes out, hopefully, is nothing but water and super microbe stuff. After we get past this point here, we definitely don't want paper. We definitely don't want waste. We want nothing but water and super, 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 super fine micro pieces coming out through here. Now, we need to have clean outs through here. So because, if we have designed this system properly and we take care of it, remember, I'm gonna put a little cloud around that living portion there. All right. Let's say that this septic tank is a 2,000-gallon tank, which is pretty good size, by the way. And it houses, it serves a house with one person in it. But this person throws cigarette butts in it. He puts his bleach in it. He puts his Drano in it. He puts all of these terrible chemicals in it. And there's nothing living in here. He's killed off everything. Then nothing's going to happen to this poop. It's just going to pile up, and it's going to pile up, and it's going to pile up, and it's going to go over and pile up over here as well. And then he's going to have to call the Roto-Rooter company or the the honey wagon is what they've called it around here in Burke County. And they're going to have to come out here and they're going to have to put a pipe down in here and they're going to have to suck all of this out. Okay. So how can you keep this a living? Well, you put microbes in it. You buy stuff like Ridex. This is Ridex, and it's nothing more than bacteria. Nothing more than just little bacteria stuff that goes in here and eats up all the poo. Okay. And it breaks it down. What else can you do? You can put yeast in it. All right. So, you know, let's say that you've had this active yeast in your refrigerator for a year. It's probably not going to, you're not going to get the effect out of it in your bread that you're wanting to. What do? Throw it in the trash can? No, take off the lid, flush it down the toilet. Okay. Anything that is yeastful. What about yogurt, spoiled yogurt? Pour it down the drain. Okay. It's full of all kinds of enzymes and stuff that's going to keep this in a living state. Try to not pour bleaches down your toilet. Try not to pour, definitely don't pour your turpentine, your gasoline, or anything else down there that's going to explode. All right. So there's a lot of methane that's going to be built up through here. You don't want to add any more fuel to the fire and end up with an explosion. God knows what, two chemicals going together can cause. You know that mixing ammonia and bleach together or chlorine will end up causing a deadly gas. You don't want to take a chance of that shit coming back into your house for sure. So keep this living. Don't, when you're picking up your cleaning agents, see what kind of, turn it over and look at, read about it, do some research and find out what's going to keep this septic system living correctly and nice forever and ever and ever. And you will never have to clean this out. Our particular septic system in our house serves 7 people. It is the same size that my parents put in here in 1966 that served 3 people. And we did have to extend the drain field a little bit, but the septic tank itself in 50 years, I'm 54, it's been cleaned once. And that was only because when I renovated the house, I went ahead and decided to clean it out. But as long as you keep it living healthy, you're never going to have a problem with it. So let's keep going. So once it leaves the, let's see, I might be on the wrong one. Yeah. Okay. So once it leaves the septic tank, a couple of things happens. So we have to get it into our drain field, but sometimes we have multiple drain fields and we have to go through what is called a distribution box. All right. So let's stop for just a second and think about how do they size the drain fields. So we have the house, we have the septic tank, we have the distribution box, another distribution box, another distribution box, and then we have the drain fields. All right. These pipe here have holes in it or slits. In the old days, this is what they looked like. Most all of them had, one side of it had some holes in it. Nowadays, no, that may not be a good picture. There we go. Good picture. All right, nowadays they just cut little slits into them. And these slits are all the way around, not just on one side. There we go. There's the holes only on one side. So let's think about that for a second. We have we're going to cut through here, and we have our drain field, and we're going to put this, where do the holes go, up or down? They go down. Okay, they go down. Even if we were to use these over here for that same drainage system that we're talking about on the footings, they go down. We want water to go to the least. We want to catch it first and get it to this least. We don't want it to fill up to this point before it can go in. Okay, so definitely make sure that the drain holes go down if you use that type. So the number of lines, or should I say the number of feet, is equal to, you ready for this? The bathrooms, right? Yep. It's the number of bedrooms. Why is that? Well, what they do is they say that for every bedroom in a house, the first bedroom is equal to 2 people. Okay. Ma and Pa are going to be living in the master bedroom. And for every additional bedroom, you're going to have 1 person. Sally's going to have her bedroom. Fred's going to have his bedroom. George, Elizabeth, John, all the Waltons are going to have all of their own bedrooms. Okay. So the number of bedrooms equals 100 feet. Okay. So in my house, I have 5 bedrooms. So I'm required to have 500 feet of drain field. Remember what I said? We took a house that had 3 bedrooms. Had 2 bedrooms. And we added 3 other bedrooms. Before it was 200 feet. Now we had to add on 300 feet to make it 500 feet. Probably still ain't spelling right. There it is. Distribution box. This is what a distribution box looks like. This is also a distribution box, but it's for electrical. Let's put it septic distribution box. So these are distribution boxes. You can buy these fancy schmancy plastic ones, but probably this is the type of distribution box that's most likely in your area. They have these little plastic cutouts in here, and you just basically cut out whatever size pipes going in, and then you have the number of pipes coming in and the number of pipes going out. I know it's kind of hard to tell from this particular vantage point here, but this one here is the one going in. It is slightly higher than these other 3. Let me see if I can find another picture here. Got an inlet there. That's not a very good picture here. No, still not either. How about there? No. Those all look about the same. Yeah, okay. See the distance here? The distance in concrete here? Look at the distance there. This one is shallower, meaning this one sticks up higher than these other 9 that's over here. So this is the inlet, and these are the outlets. Water's going to come in through this point and is going to leave out of this point. Now, how picky how picky do we have to get with these? We have to get very picky. The not the building inspector, the health inspector is going to come, and he or she is going to test this with water. In other words, they're going to pour water into this, and it better leave all of these outlet pipes equally. And that can be kind of hard to get them all to go equally. So what we have is we have dial-ins. We have these little dial-ins. So they go in, they're just, little pieces of plastic that go on the end of the pipe. and you turn it so that one is higher or lower than the other. So that it doesn't matter if the pipe is, like I say, the distribution box can be crooked as crap, because it's sitting on dirt, and then we're going to fill it in with dirt. We're not going to run no bulldozer across it. So we don't want to disturb this, but we want to get these dialed in so that that water runs perfectly out all of those drains at the same time. I know that sounds kind of a little, well, it's kind of anal, but it needs to be done. It needs to flow through all of them equally so that they work properly. Now let's think about the distribution field, or the drain field. So the drain fields have to be dead level, all right? In this particular case, we've got one distribution box, and then we have a pipe coming out. This particular pipe has to run 1/4 inch per foot, has no holes. This pipe, this wouldn't happen. You can't do this. There has to be another distribution box here. Maybe that's not the best one to use. Yeah, maybe this is better. No, that's better. All right, so we've had the distribution box. This is a level pipe that has no holes. This is a level pipe that has holes. This is a level pipe that has holes, and so forth as this one as well. Everything from the house to the septic tank must flow at 1/4 inch per foot. 1/4 inch per foot. All right. That means that in 1 foot, then this is 1/4 inch. Why did I put a half? I just said 1/4. 1/2 inch to nothing. This is 0. So it has to flow downward. Somebody did research and figured out that 1/4 inch per foot allows water to carry waste and paper down the line without running off and leaving it. So, who would have sat around and done that? I don't know. But 1/4 inch per foot. So the 1/4 inch per foot would be in this area from the house to the septic tank, and from the septic tank to the drain field. Over here, these have got to be level. How level? They're going to come out with a laser, and they're going to, you have plus or minus 1/4 inch to make sure that these are perfectly level. All right. Let's change it around a little bit. Let's say that we're on a slope. Remember that we have to, actually, let's just go back over here for just a second. Maybe it was this one. Let's go back over to my dad's home place right quick. Actually, I'll just take you to my house. Okay, so here's my house, and notice how the contour lines go. So my septic tank sets about right here. Septic comes out, the septic line comes out to there, and then it starts, there is a distribution box immediately right there, and then the original line runs around here. Actually, it runs with that contour, and then goes down just a little bit more, and there's another distribution box, and it runs with the contour line there. That's where these were 100 feet each. So I added on to this. I come down through here, and I have a distribution box here and a distribution box here. And then I have 2 lines that run off of this direction as well. Now, there's a reason behind this. These are the old 4-inch pipes here. They are very old, as a matter of fact. In the old days, we could use concrete pipe tiles. Let me put in tile. Well, maybe I shouldn't have put in tile. Oh, I'm putting piles. P-I-P-E, pipe. Let's just leave it at that and see what I get. Big ones, of course. Fat fingers typing on a keyboard. Well, all right, so, nope, not that either. What the heck? Well, I'm not finding the picture that I'm looking for. Okay, so back to the drawing board. So in 66, we had, it was 4-inch diameter pipe, and they were made of concrete. And they were kept a 1/4 of an inch apart. There was a 1/4 inch air gap in between it, each one of them. And this was the way that these pipe drained out. All right, and that's still what is right here on these orange ones. These are original ones. Those are the 4-inch diameter. But down here, I could get away with making this shorter. Remember that I added a couple of bedrooms to this, and I was told that I had to add 300 feet to this. So I didn't have enough space to add 300 feet to that. Because this is what they consider my repair area. So when they design this, they design by adding this on here. And then you have to have an area on here so that if something ever happens here, then we can move to this area, and this is the repair area. So I couldn't do 300 feet here. So with the, let me just say this, with the 4-inch pipe, you know, this is the kind of corrugated pipe that would go in. All right, we have to go a full 100% distribution on our drain field, 100 feet per bedroom. But in order to get away from this, to shorten it up, I can use, I lost the term all of a sudden, chambers. Drain. So these are chambers. They're approximately 36 inches wide and about 2 foot or so tall. And depending on what manufacturer you get, these are going to be different sizes, obviously. And you can, you can have different, you can do, small to large. These are all chambers. Now, by using a chamber system, I don't have to have as much. We call this an 85% reduction system. So instead of 300 feet, let's see what we have to have. 300 feet times 0.85 gives us equals times, well, it's going to lock up 300 feet times 0.85 equals 255. That don't sound right. Let's try it again. 300, maybe it is 300 feet times 85%. Yes. Okay. So it is 255 feet. I know that don't sound like a lot, but in here, 255 feet instead of 300 feet. So I saved basically 50 feet in here by using the chamber system. So it saves money as well. So when we do a conventional 4-inch diameter, all right, so this is the 4-inch diameter, 100% drain field. Basically what was happening is you have to dig a hole, or you have to dig holes depending on how many drains you have. And they must be 3 foot deep. They must be 3 foot wide. And you're going to fill that. You're going to put your drain in here. And you're going to fill it with 2 feet of gravel. And you can cover it with 1 foot of earth. Okay, so this gravel in here is washed. You've heard me say that before. Washed gravel, washed gravel. And then, of course, you can put earth. You can put 1 foot of earth on top of that. Again, 3 by 3, and they can be no closer than 9 feet. Okay. Chamber system. Or an 85% system. We're going to dig a hole, 3 by 3, 9 feet apart, center to center. We're going to drop this chamber in here. And we're going to fill it up with dirt. End of story. All of this gravel, let's think about this. In order to get to this site, all right, we're going to have to get an excavator or bobcat or backhoe or something in here to dig this. A bobcat, a backhoe, an excavator, they can get on a hill and they can dig. Now we've got to get tons and tons and tons of gravel in here to put in here. So washed stone is equivalent to, I think, 1 cubic yard of stone, of washed stone, is equal to almost 1.5 tons. Okay. We're on a slope, may have snowed, may be rainy. The ground outside today at my house is still kind of mushy. So I've got to get a backhoe, doggone it. I got to get a dump truck up here so that I can put this gravel in here, or I'm going to end up running a hole in the yard with the excavator or the bobcat back and forth between the dump truck and these trenches. Over here, I get my little excavator up in here and I dig in here, and that's the end of the story. The excavator leaves. Well, he's not going to leave yet, but I'm going to put my chamber systems in, and then I can use the excavator to cover it up again, as long as I don't drive over it. Do not drive over don't drive over these either. Don't drive over your septic tank. Don't drive over your drain fields, and you will have an okay time with that. So, and that's it. I mean, you can carry these things in by hand. These are very light. I think I carried about 4 of them at one time. They're just bulky. They're about 5 feet long, and they're 3 foot wide, and they're just thin plastic. And as you can see, all you do is you just cut holes in the sides of it and feed your line into it and walk away. There's one with the lines in it. You don't necessarily have to have it at the top either. Mine go in at the bottom. It just leaves room for the water to just, you can use your imagination. You're using the garden hose, you throw it on the ground, and the water from the garden hose just goes out. And, I guess I should have just found this here first. So there's your conventional type, and there's your your chamber system on there. So there you go. Any questions about this?
How in the world can we build any of these houses up on top of these mountains and need to run that stuff straight?
A very good excavator operator. It's the whole thing I can tell you. But yeah, they, for sure. I love how all the pictures are, you know, on flat ground. Let's just drain field on mountain. What I need to do is just take you to do some videos.
I've got a couple pics from some sites on mountainsides. I can't believe that they've been approved.
Not very much. Well, maybe if I spelled it right again. Nope. There gives you, I mean, there's a mental picture. All of these are running level. They're just running down the slope.
Yeah,
Yeah,
so
I guess
they'll
I
let
need
you
to
downslope to the, they will let you downslope to that, the combiner boxes. So you can
Yeah.
drop slope from one box to another.
You can slope from one box to an, yes. So you can slope this a 1/4 inch per foot, but it can't be, you know, you can see where the drain starts. This is 1/4 inch per foot, but you can't drain it at this point. You can only drain it on the levels. Does that answer your question?
I suppose so. I'm just wondering, I know that there's going to be some situations where you're going to have to drop more than a 1/4 inch per foot to stay under grade. Because grade's going to drop steeper than that.
Okay, you're right. I'm sorry. This has to be a 1/4 inch per foot. This has to be a 1/4 inch per foot. This does not have to be a 1/4 inch per foot. Sorry. Because there's no
doesn't have to
waste.
deal with the waste. Yeah.
Yeah, you don't have to deal with the wastes. Yep,
Got it.
sorry, told you wrong. I like that one. So you can slope down, but then that point, you got to be level. You can slope, level, slope, level. I don't think that would work because you've got to be able to get all three of these distribution equally, and they wouldn't approve for that. Not in North Carolina, not in Burke County, maybe some other places, but not here.
Looks like you'd need a box on those corners too.
Well, see, you got to be able to, hang on. According to what I understand, you have to feed this. You got to be able to feed this, 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 and this all at the same time. Okay, so meaning that this is going to fill up first. In this case, this is going to fill up first, then this, or actually it's opposite way. This is going to fill up first, this is going to fill up second, and this is going to fill up third. I don't know. But from what I understand, we would have to have this ought to come over here. There needs to be a distribution box here, here, and here, and feed them this way. That's my understanding. I might be wrong.
It looked like to me too.
Yeah, I might be wrong. Okay, it is approaching 3 o'clock, and I can feel my voice starting to get a little rough. So I think I am going to shut up. Let me make sure that I got over everything that I needed to cover. I believe so. So, what is today? Thursday. Tuesday. Remember that you guys don't have class on Monday. It's a holiday. You got a 3-day weekend. Woohoo! So on Tuesday, we will start masonry. You have 2 weeks to complete the foundations and site work quiz. And then on Tuesday, the masonry module opens, and we will begin talking about concrete and block and brick and mortar and all of that good stuff. Anybody got any questions? Everybody?
sir.
Okay. Everybody understand everything that I've talked about today, right?
Yes, sir.
Everybody good? All right. Okay, until Tuesday, have a great weekend, great holiday. Stay safe, have fun, live a little bit, wear your mask and all that good stuff. See you then.
See ya.
We'll see you later.